All right, so it is word problem day. Let's do it. So the first one, I just made this up. First one is the amount of toxic fumes measured in Stanky units, or SUs, left in the family truckster after a road trip to Florida can be modeled by f of h equals 2,000 times 0.87 to the h power, and where h is the number of hours after you get to your destination. So, first question, how many fumes are there in the vehicle when you get to your destination? Valid question. Okay. Well, what is the time when you get to your destination? How many hours, because that's what h is being the label, measurement is, how many hours have you been there when you get there? When you get there, how many hours have you been there? 0, right? Okay. So h is 0. I thought you said 2. Oh, it sounded, from up here, it sounded like 2. Okay, I apologize. It did, that's why I was looking at you, probably like, 2? Where are you going with 2? Okay, so h is 0 here. So we need to plug in 0 for h in our function. We need to find f of 0. Well, that would be 2,000 times 0.87 to the 0 power. Anything to the 0 power is? Anything to the 0 power is 1. Okay? So 2,000 times 1 is 2,000. So there are 2,000 Stanky units in the family truckster. Okay? How many fumes, measured again in Stanky units, how many fumes are there in 24 hours? What's h now? 24. So find the h or f of 24. So I would say that there is approximately 70.7 Stanky units left in the vehicle. Agree? Okay. If the human nose can't detect a smell with an SU value lower than 7.8, when will the vehicle return to its normal smell? What do we do in this one? How am I going to go about solving this one? Exactly. Because the original equation is the measurement of Stanky units. Okay? So if my 7.8 is the Stanky unit threshold for the nose, we would set the function equal to 7.8. So we would have here 7.8 equals 2,000 times 0.87 to the h power. We want to solve for h. How am I going to solve that for H? Can't yet. Can't yet. Divide by 2,000 first, because what do we have to do? Isolate, the first step. Isolate, then switch forms, then solve. Okay? So we first have to divide both sides by 2,000. Now what? Now we can switch forms. We've got our exponented term isolated. So this is going to be log. What's my base? Of this, right? Find me that value. So I would say approximately 38 or 39.2 hours. Oh, sorry, quick. I was looking at the next one. My bad. Okay. Pause for the cause here for a second. So, then, you do this one. When a plant or animal dies, it stops acquiring carbon-14 from the atmosphere. Carbon-14 decays over time with a half-life of about 5,730 years. This means it takes 5,730 years to lose half of its carbon-14. So if it started with 5 grams of carbon-14, in 5,730 years, it's going to have 2.5 grams left. Okay? So that percentage P is given by that equation. Answer me those 4 questions. So just by reading the problem, we should be able to do letter A, right? How much is left after 5,730 years? 50%, right? Okay. If you didn't see that this was 50% left over, then you would plug in and you would find P of 5,730. So you plug in, so you go 100 times 1/2 of 5,730 divided by 5,730. That's 1. 1/2 to the first power is 1/2. 1/2 times 100 is 50. Either way. Okay. What percent of the sample is left after 2,000 years? Well, now we're going to have to plug in 2,000 into our function. 1/2 2,000 over 5,730. Need my calculator. Found it on 100 times 0.5 raised to the 2,000 divided by 5,730, and I get 78.5106. So we'll call that 78.5% is left over. Agree with me on that? Okay. Part C, what percent remains after 20,000 years? Well, that's going to be 100 times 1/2 to the 20,000 divided by 5730. I got 8.89784. So let's call it 8.9%. Agree with me on that one? Okay. And then the final question, when will the sample have 1% of the original carbon-14 remaining? So that's going to be 1 equals 100 times 1/2 to the t over 5730. Isolate my exponented term, so I'm going to divide by 100. Oops. Then I'm going to switch forms with it. So we would have log of 1/2, or log base 1/2 of 100 equals t over 5730. That, and then I would multiply both sides by 5,730, and that would give me 38,069.29597 as my t. So I would say 38,069.3 years. Yes? Yeah. Questions on that one? Let's do part A together, writing the model, and then you guys can do parts B, C, and D. Okay? So Ms. Hoff searches the couches in her home for loose change, and she collects it. One year, she collected $207. A lot of change in the couch. She put this money into account for a rainy day that pays 4% interest that is compounded monthly.
Good morning, Los Angeles. Sorry for the interruption.
Bus 10 and bus 4 always cancel. All right. So, if it's compounded monthly, how many times a year is it compounded then? 12. Sorry, I didn't hear you. My bad. Why are you yelling at me? Give me those judgy eyes. Okay. Okay. So my model then that we would write would be A. That's the amount that we have in the account at any given time, is equal to P. P by the key is the starting amount. So how much money did she deposit? $207. So P would be 207. 1 is 1 plus R. R is my interest rate. So which one? 0.04 is 4%, right? 0.4 is 40%. So this would be 0.04. divided by n. N is the number of times compounded. We just said that that was how many? 12. To the 12t power. Okay? So that's the formula that you have to come up with first. Now we can use that formula going forward. I would leave it as 0.04 divided by 12 because that's going to be some really ugly looking long decimal. And so then that way we're exact. The more times that we can be exact and less rounding we can do, the closer we are to the exact amount. Okay? So with that said, you now answer parts B, C, and D. So then this would be A equals 207, 1 plus 0.04 by 12 to the 12 times 5. You just basically plug that right into your calculator as it is. You might have to put parentheses around and put 0.04 divided by 12. 7. Get 252.746, but because this is money, that's going to be 252.75. Cents. They just drop it. We'll round up. We're not a bank. Okay. 15 years, same one, except change the 5 to 15. Again, it's money, $376.80. And lastly, when will the account have $1,000 in it? Now we're going to say 1,000 equals 207 times 1 plus 0.04 divided by 12 to the 12t power. So I would first start out by dividing by 207. Then I can switch forms with it. Figure out what that log is equal to. I get here approximately 473.298 equals 12t. Then I'm going to divide both sides
say, in 39.4 years, that account, just from the $207, will have that much money. Very few banks compound monthly, quarterly, daily. Most banks are all continuous compounding, and that's PERT. A equals principal times E to the rate times the time. Okay?
That's all I got for you for today. Tomorrow we'll do some reviewing, make sure we're all set to go with logs and exponentials, and Friday we'll test.